Hello. How is my audio? Let me check. There's a bit of a lag, so I was like, okay. All right. Cool. It looks like, let me get out of that. So I brought up the stream on my laptop and I just wanted to get rid of that lest I cause a loop. How are you all doing today? I actually, it was one of those things where I was kind of a little concerned because I had to reboot my laptop just before the stream started. And so like the camera wasn't coming up. Probably because I had been doing some stuff. I've been disconnecting things. I'm having I think allergy issues. It's a mason jar full of water and like a crystal light kind of powder. Anyway. So yeah, sorry. I'm just making sure that I have everything where it needs to be before we launch into it. Which also reminds me I need to... Okay. And yeah, sorry. Like I say, I literally just rebooted the computer before the stream. Let me see. Okay, we got Siril. And we have my desktop. Great. Okay. Hi there. Yeah, so I'm here. The audio seems okay, so we'll just go right into it. So yeah, the main topic that I wanted to talk about was taking exposures with like how long is too long for taking an exposure, taking photos with a Seestar, and kind of digging into what the differences are when you do that. Like what kind of differences will you see? Sorry. But before I got into that, there were a couple other little odds and ends. Monday will be, as of the recording of this, on Monday it'll be 6 weeks until the solar eclipse, which is, yeah. I'm the most prepared I've ever been for a solar eclipse, but I still feel like I still need to do preparation. But I'll be coming out with a video this week, and I'll be talking about it some more. Not in this stream, but we'll be talking about it again. I wanted to talk about the integration time or overall exposure. I also wanted to mention a supernova, which I'll do that last. Because that was kind of interesting. I mean, there's always supernovas going on somewhere, but yeah, we'll talk about that in a moment. So the first thing I had put something out on the community wall about specifically Orion, and Orion is a very bright target. But let me take a step back. So, hi. Yeah. I haven't added the 20 and 30 exposure settings yet. Yeah, I actually I need to. I forget if I was going to go over that this actually I will. I don't have the chart, unfortunately. Um, thank you. Thanks JCL for Thank you for the kind words. But but basically, just taking a step back about the terminology, some kind of, and I might be imprecise at times, but I'm going to try to stay some level of precision with what I'm talking about. But when you take a photo with, especially with something like the Seestar, where you can just kind of point it at a target and you hit go, and it just kind of starts accumulating information, and you can see the photo improving gradually. And what it's doing is it's doing, I mean, you can see it on the timer, it's doing like 10-second exposures. And so the what I'm going to try to talk about is like the overall picture, the final picture, which is an accumulation of all those individual exposures. And the integration time, the total integration time, you'll sometimes, it's usually called total integration time, is basically the sum of all those. So if you have 10-second exposures, the total integration times 100. So each individual photo that the Seestar takes, each 10-second typically, is, you'll hear it, it might be exposure or subframe or even a light frame, which is to distinguish it from calibration frames, which again, the Seestar is doing some of it internally, but it doesn't really expose it to you. So we don't really worry about the calibration frames typically. So basically it takes a bunch of short images, does some processing, and then it produces the final image. And that combination helps in several ways. If there's some like little shake of the telescope while it's taking the photo, it just ignores that. It also helps with things like noise with the sensor. Like if you ever take a photo with, I mean, for those who haven't done this, but like if you take a photo with a camera of something dark, it gets grainy because of camera noise. And astrophotography is just an exercise in that all the time. Yeah, so the best to stay with 10-second exposures. It's interesting. I might get to that. I was going to put it in a video, but I might as well mention it now. So I have definitely found that the 10-second exposures are best, or they work in the general case. The longer exposures, the 20 and 30-second exposures, do work, but a lot of it, they tend to have better success if the object you're taking a photo of is in a certain position in the sky because of field rotation. So I'll show this with some of the examples of that I'm going to get into today with Orion, the Orion Nebula, that basically, so if something comes up in the east and it just goes straight up, essentially, the object isn't really kind of, it's approximating a straight line up. And so if you increase the exposure duration, it'll or the amount of time it spends on each subframe, it's fine. But if on the other hand, say the object is more towards the south, or it's doing kind of an arc in the sky, and it's like at the top of that arc, it's rotating more effectively, the object. And that's something you'll see with these images of Orion I was taking, because I was starting the exposures when it was pretty much close to almost due south. And so it was going kind of through the most field rotation while I was taking the exposure. So that would have been a terrible time to use longer exposures. But I think in some situations, the 20 and 30-second ones are fine. Just unfortunately, I don't think it's very useful to me because I have obstructions to the east and west from my house. And so everything is it's varying degrees of field rotation. But so getting back to kind of the exposure duration, that overall exposure, the total integration time. The Orion Nebula M42 Messier 42 it's a great target, and you get a very good image pretty quickly because it's so bright, and it's sometimes like it all like you could look at an exposure that's like 5 minutes long, and then you look at one that's 30 minutes, and especially right out of the Seestar, it might, like on the surface they look similar, but when you start getting into some of the details, you'll see differences. And it's especially true with something like M42, where it's a very bright object. You definitely see a bigger improvement with fainter targets. But so for this kind of, yeah, I think so. For the longer exposures, I think if it, I found someone had done a chart, a visual on kind of the position in the sky versus exposure duration versus field rotation, and kind of visually kind of mapped out when you can use it without where any rotation would be so small it would be negligible. But I don't have it handy, unfortunately. I need to find it. I think I made a note of it somewhere. Oops. Yeah. So yeah, I need to I'll probably drop a description or drop a link in the description or in a comment on the longer exposures. The Orion Nebula picture with Sirius. Yeah, the Horsehead is it's a fainter subject, and so I've the single longest photos I've taken with the Seestar. It looks reasonable, and you can tell it's there, but I think really you have to take a lot more photos and then combine it, like outside of the Seestar, like with Siril, to get it to show up. And yeah, I think I don't know that the filter. I mean, there are people who there. I saw a 3D printed adapter for the Seestar. I haven't gotten it, and I've seen some people online who've had it, where you can attach standard filters to it, and they've used that to take photos through the Seestar with like dedicated HA and O3 filters, O3, and but I haven't done that. It might produce better results, but I think ultimately it still becomes an exercise, and you just need more total integration time to get the results, to get a great exposure. Because a lot of those, like, this is always the problem when you see things online where somebody's taken a photo of a target and it looks amazing, but then when you look at how much time they spent on it, of how much integration time, where it might be 5 hours of total integration time, and with a bigger telescope. And so, yeah, so this will be interesting. This is maybe it's kind of the what I wanted to do here is, by showing M42 and then different exposures, you can kind of see how it really scales, or how it improves. But then with fainter targets, you just need that much more data. So because I had posted on the community board, I feel like I'm scattered this afternoon. Sorry. On the community board, I posted 3 photos that I had taken of Orion, but they were taken on different days. And so I thought that I'd be more rigorous about it. So I did 2 different series of images on Thursday and Friday. And for various technical reasons, I'm kind of constrained by the buildings around me, and also on Thursday, clouds started rolling in. Plus the full moon. It's essentially a full moon, and so it's it was kind of a challenge, but it's a good exercise because they were apples to apples comparisons as far as being able to see the like you can make a more direct comparison. A field reducer, I've thought about that too. I haven't looked into it to see if anybody's done it, but especially for targets like the Orion Nebula, where you can get the Orion Nebula, most of it, but then you don't get the Running Man Nebula, and you can't take a photo of all of Andromeda. So it would be nice to have like a field reducer, an adapter. I need to look into that because I wouldn't be surprised. I mean, people have been doing some creative things. Sorry, I need to take a drink. Here in Texas, it's already starting. Allergy season's already starting. It's like we have such a short winter. It's anyway. So let me get to the images here. Actually, I hope I don't mess up the stream. I know that's always one of the things you want to hear on a stream is like, I hope this doesn't mess up the stream. Oh man. Hopefully this won't drop it. Okay. Okay, it didn't drop it. I had to I wanted to rescale my screen because it was very what do you call it? Very high resolution. I was afraid that it would be kind of a pain to look at things. So let me see if this works. Okay, great. Great. Okay, at least this works. Obligatory photo of the moon I took the other day, since this is basically what I was up against. If you've been out taking photos the last couple nights, last night was the full moon, or about last night? But this was Thursday night. It was pretty full. But what I wanted to bring up is, so these Orion exposures, those are the ones I put on the community board, so we're not going to look at that. So day one, I did a 1 minute, 6 minute, 10 minute, and 37 minute. I meant to make it a 36 minute, but I went a little too long. But I'll open these up separately so we can look at them side by side. But so and these are the images that came right out of the Seestar, no processing, downloaded to my phone, and then dumped onto my computer. You can tell because of the kind of caption at the bottom. So this is the 1 minute exposure, and it it's not bad. Orion is such a bright target. I mean, given that this was Thursday night, I was dealing with the moon had already risen. There was some high haze, not where Orion was, but in the sky. Plus I'm Bortle 8-9. So now we see 6 minute. So if you look, you can see more detail here, obviously. And you can tell, like up here where you kind of have this faint nebulosity, it's more pronounced in the 6 minute, but it's also less grainy. Now here's the 10 minute. It's just, see, 6 minute, 10 minute, just that much brighter. And then 37 minute, you can really see, like compared to even the 10 minute, like some of the nebulosities less grainy. I'm also going to bring up the fit files, the raw files in Siril in a moment, but I just wanted to start with the JPEGs because some of the differences are a little bit more subtle. You can also see as the sequence went along, how it rotated in the sky. One thing you're starting to see in this image, the 37-minute, is down here you have some nebulosity, which that you could barely make out in the shorter exposures. So I'll get to the raw files in a moment, the fit files. So this was day 2. Again, we started off with 1 minute. Now this I included this one in the sequence. See these lines here? It wasn't windy, and and I saw this in the preview, and I ran across, it's happened a few times, and I saw mention of it online in the forums that basically it's not clear what causes this. Like it's not a physical thing with the like vibration or wind. It's something else. The something else is when I was looking in the live view and I was trying to move just before I started the exposure, I was trying to move the telescope. It got to a point and it went up and down really quickly in the live preview. And I think that's what's happening here. I don't know. I'd seen some mention of it that ZWO Seestar was looking into it, but they haven't been able to isolate the issue. But it may be, there was a question about this a few weeks ago on one of my videos. I think this may be some kind of, it's not clear if it's a tracking glitch or something. But it didn't reoccur, which was interesting. So here's 1 minute, 3 minute, 11 minute. You can see how much brighter it is. And you can start seeing this kind of nebulosity down here. And then 52-minute, it's just that much more. But you see how massive the field rotation is here. So yeah, unfortunately, I've found that I have a hard time going beyond an hour total integration time in one session, because it ends up being you get too much rotation. Oops. Yeah. So, are you talking about like the lines on the stars? Are you talking about these lines? But yeah, it was kind of it's interesting. It hasn't happened. I've taken quite a few frames at this point. Okay, yeah, yeah. I think it's some kind of tracking glitch. Because in the past I thought it was something like wind or something, but then when I had seen on the live preview, I'm trying to like make fine controls, and it's kind of like I expected it to kind of move like this, but it went like this on the screen, but I was only going one direction. And so I'm wondering if that same kind of little glitch is happening when it's trying to do frames. Yeah. Yeah, it's a strange one. I need to dig into it more, but I saw someone allude to the fact that they're aware of it and they've been trying to get to the bottom of it. It's weird. Like I say, it doesn't happen that often for me. There's other times where I've had glitches that were definitely wind or something else, but in these kind of cases, it's unclear what's causing that. So let me get back to the, so those are all the JPEGs. So what I'm going to do now is let's switch to Siril. Let me bring up Siril. Okay. So what I wanted to do is actually, just for the sake of, because the problem is those JPEGs, that come out of the telescope are processed, but it made certain it made certain assumptions and made certain choices for us. And so by looking at the raw stack files, there are still some choices that were made. It might give us kind of a better idea of what is actually in the raw image. Yeah, I'll get to that. You're I'll get to that in a moment. I'll show you kind of I'll show you something. I have something to show. But first I wanted to get to Siril, and let's go change the home directory. Day one. So let's go look at the fit files. Oops, I need to. I've got like my streaming overlays on the screen, so like I have windows you can't see but that are in my way. Okay, so let's go. What I find useful for this kind of exercise is turning on histogram mode, where it kind of just maxes out the stretching, so you can really see the extent of the yeah, yeah, it cropped off to the left. Yeah, I'll get to that in a moment. Actually, let me bring this up. So I I like having it in histogram mode because you can really see kind of the extent of where the data is. So this is the 10. Wait, did I open the right one? Oh yeah, yeah. Yeah, this is the first one. So this is the 10 the 1 second exposure. So that is doing like two-handed thing here. Oops, wrong window. So that is day one. That is this one. So if you see this image, and then kind of this is the same, this is the raw data from that image. So you can kind of see it's actually, let me put both on screen at the same time. So you can kind of see, let me try to put it on screen at the same time. Oops. You can see the extent. Oh, this window. Sorry. So you can see, well, besides the fact it's flipped, you can see there's actually a lot of there's data in there that it's not showing, probably because it's too faint and it would look bad if you try to bring it out. But so that's the 1 second. So let's look at, actually, let me not look at every single one of them. Let me skip to the, so this is the, I mean, not one, it was the 1 minute, and now this is the, which one is it? 10-minute. So this is the 10-minute one. And you can see, if we compare it to the, you can see, like bouncing back and forth to those, going from 1 to 10 minutes, it's got a lot more detail up here in the kind of raw data. Whereas like this whole section right here, whereas if you look at the other one, like you really can't make it out. And then if you look at like this M43 area on the 10-minute, I keep picking the wrong one. On the 10-minute, there's more there, but you're definitely seeing more up here. Now, if we go to the, now this is the 37-minute one, and you can really see like this part is starting to really kind of shape up nicely, whereas here you can barely make it out. So since it's starting to show up in the kind of the underlying raw data enough, it's kind of meets that threshold where it starts getting visible in the JPEG. So you can kind of see it really faintly down here, whereas there's actually a lot more data there. So again, this gets into that whole exercise where if you process it with Siril, you can kind of pull some of this out. Now it might not look great, but you can at least do it. So that, I'm going to skip over the day the day 2 shorter frames and go right to the 52-minute one. And so, yeah, see, you get this massive cutoff here. And so I'm comparing apples to oranges, or apples to apples, sorry. So there's the 52-minute. And then this is what it looks like, the fit file. And again, you get the massive field rotation. Actually, let me flip it. Okay, so now we're looking at the same orientation. So you can see, like in the JPEG, it shows a bit of detail down here, but there's actually a lot more down there in the raw image. But none of that was visible in like those 1-minute exposures where you can see, like, I mean, you can kind of see there was something there, but really, it didn't save that it was flipped. But you really see that, like, going from that 1 to 10 to 50-minute. You don't necessarily see the huge improvement in this area, but you can start seeing more detail here. There's also more smoothness. Let's look at that. See how this is grainy here, but this is pretty smooth. If we go back and look at the 1-minute, oops, you can see it's grainy down there in the M43 area. And then even at the edges here, it's grainy. And that's reflected in the JPEG. If it's grainy in this view, it's definitely going to be grainy in the JPEG without some kind of processing to... But even then, a lot of times you can get rid of some of the graininess, but you end up losing detail. So it's a trade-off. So that kind of, that makes sense. But then I decided I wanted an even longer exposure, but I wasn't able to get that in one shot. You can see because of the field rotation. So I went ahead and did it manually. I combined all the frames all the frames that went into all those photos you saw, like a lot of them. There were over 700 frames, so over 2 hours of frames. So I thought I would try processing them. And so let's look at, so let's compare this with what we have here. And now you can really start seeing, like, there's a massive amount of detail here that wasn't visible before. And that was, now granted, it's not using the Seestar stacking, this is Siril stacking. So it might be, it's not that it's necessarily doing a better job. It might be that it's just using more, it's able to throw more resources at it. Like this, when you do some of this stacking in Siril, if you haven't done it before, it was using like 4 gigabytes of, or 5 gig of RAM, which I'm pretty sure the Seestar doesn't have that much RAM in the whole computer. So, and that was just, Siril was using, actually it might have been more than 4 gig. But yeah, you can really see that it's and then the other thing of note, notice the rotation's gone. I mean, there's still artifacts here at the edge, but because it kind of averaged out a bunch of exposures that were in different stages of rotation, it was able to kind of average out some of the rotation. And so that's another neat, useful thing. Now, the one thing that I did with this, when you pick Orion, it tends to put kind of this trapezium area in this, like near the center of the frame, or like right here. It tends to be more centered left to right, but then the problem is you end up losing kind of all this all this part down here, like, and so what I ended up doing is, after I told it to, the Seestar, to go to M42, I then kind of manually adjusted the, oops, don't know what I just did there. Okay. I manually adjusted the position just to get it, like basically you can kind of see in this one, it would have been over here, and like the trapezium, like this core area here would have been here. So I just kind of moved it to the side and then up. So, and then I took an exposure, and the first time I did it, I had to stop. But then once I realized where it needed to be, then I just kind of let it go. And that way you can get more of kind of this part of the nebula. Uh, oh, hey. Hey there. Hi, Gary. Um, I I was just on. Gary was live streaming. Was it last night or the? I think it was last night or the night before. The days blur together, but I was on his. He has a. He had a Seestar. He was live streaming his Seestar, and it's pretty cool. He has much better skies than I do. Um, but let me. So just to I'm clicking on the wrong window, but just to kind of bring it home even more. So if I bring up this image of, this is the 52-minute exposure. And then if I bring up the combined one that I had manually processed. Now I didn't apply all the processing I normally yeah, the days get blurred together. But so you can see I took, now again, this isn't like a one-to-one comparison because the Seestar does its own processing, but it's still kind of, actually this one is because of the massive field rotation, and it was also a bit brighter because of the full moon. Let me bring up this other image of day one, the 37-minute exposure. Okay, that's a little less annoying. So this one on the left is 37 minutes, and this one on the right was the 2 days combined. Now, there were clouds going through, so I ended up having to exclude like 70 or 80 frames, I think. 90 frames. It ended up being 109 minutes of data on this one. But it's not, I mean, it's not quite apples to apples. So like one thing is because it's a bigger data set, like the cropping is slightly different. So that can kind of be misleading. So let me see. You can kind of, what I do sometimes is kind of look at these stars and figure out, no, it's pretty close. It's pretty close. Because if you look, this star, these, oh, wow. So these two stars here are the same as these two stars. But if you, as you can see, in this one, you get a lot more detail kind of over here that you don't get here. And then of course there's this whole area down here. And I didn't, in Siril, I didn't do anything like the generalized hyperbolic stretch. I just did their kind of default stretch, the histogram stretch. And I increased the saturation a little bit. I didn't do star extraction. All I did is I did background extraction, and then the histogram stretch defaults, a little bit of saturation. I was trying not to weigh things too much towards Siril, but you can, so I feel like this, I mean, it brings out more of the faint detail, but it really shows you that like more detail, because with the 5-minute exposures, there wasn't enough down here to really bring that out where it wouldn't have been totally grainy, or you wouldn't have like kind of overexposed other parts of the image. But yeah, I mean, and then if we compare it to the beginning one, the 1 minute. So yeah, you get from, actually not 1 minute. Let's do like a 6 minute exposure. So you go from 1 minute, you go to 1 minute. Oops, sorry. You go 1 minute, and then you have, I'm trying to keep the screen relatively small so it doesn't oops, so it doesn't there we go. Okay. It was because one was on top of the other. Okay, so here you really see 1 minute, 37. Oh no, 6 minutes, 37 minutes, and then 109 minutes. And again, this last one, take it with a grain of salt because it was processed differently. But you can really see, you can't kind of get, just going from the 6 minute to 37 minutes, you're getting more detail here. And actually, if anything, this 37-minute exposure, the moon was higher in the sky when I took this photo. So I actually was fighting more, the Seestar was fighting more light in the sky. And yet you can see more contrast here. Like this bit is grainy, you can kind of see finer wispy details here and here. And then of course when you accumulate several days and just a couple hours and run it through Siril, you end up with like a lot of detail. But yeah, so yeah, so on no, on the app, I don't know if I can bring it up. You go into advanced settings, and so once you've connected to the telescope, you go to it. The raw settings are, I think, mostly for like planetary and sun and moon modes. If you go to planetary mode, well, okay, let me take a step back. Yeah. It's so out of the box, without doing anything, the Seestar will save these fit files, these ones that I was initially showing inside Siril, and you can process these, but they're not. But you can't do what I did with this last image, where I combined several days worth of data. For that, well, you could theoretically, but ideally what you need to do is you go into settings, or you click on the telescope icon in the upper right, go to advanced, and then there's like save individual exposures. And when you do that, it will create all the 10-second, it'll save all the 10-second fit files. That's a mouthful. But you can see in this directory here, all of these frames, these hundreds and hundreds of photos. You have to have that setting on. And then once you do that, when you plug the Seestar into your computer, which I actually did a short video of that, it would, yeah. I did a short video on actually how to dump that, but I need to do something, but I need to find that video. But basically if you want the individual fit files, the 10-second ones, you have to turn on the setting. If you don't, you still get a fit file, the one that was pre-stacked, which were the ones I was showing in the beginning, not the one that like the 100-minute one. Yeah. The stacked fit onto Siril. Yeah. What Alex said. Basically, you can get you can even see the name of it. So these are called light, are named light, but if you look at the ones, these are named stacked. This is the name that was saved on the Seestar itself. So you can see these are the files. but these are already pre-stacked for you. It says 10-second, but that means it was 10-second subframes, but the whole thing is still stacked. Yeah. But you can start with these if you haven't turned on that setting. But I recommend turning on that setting because it gives you more flexibility. You don't have to use it. It does use more space while it's taking it, but I found it takes a while to fill up unless you're doing like multiple multi-hour sessions. It takes or video will take it will burn up space pretty quickly, but the photos, the subframes don't. It takes a while to fill it up. So yeah, that was kind of the differences, kind of in exposure length. That was not all. I wanted to mention this supernova. So there's always supernovas going on, and this was actually ended up being kind of a rabbit hole, but I thought it was an interesting rabbit hole. Basically, long story short, there's a supernova in a galaxy NGC 4216, which is available. I mean, it's available, visible about in the middle of the night, after about well, from my backyard, I can't see it until about midnight or 11 p.m. But if you have an unobstructed east view, you can see it earlier. But what I thought was kind of cool, I'll try not to. I'm not going to go and spend too much time on this. But what's interesting is, they always say like supernovas. If you've ever heard this about supernovas, they can temporarily outshine the star that they're in. So I took a photo, and I was pleasantly surprised that I was able to pretty quickly get a photo of it. And I was like, at what point is that actually visible? So I screen recorded the Seestar app while it was accumulating data, and here's the video of it. And this is sped up like 5-fold. Is this the video? Oh, no, sorry. Yeah, this one. So you can see, and I zoom in and I turn on labels. So you can see here's the galaxy, and that's the core of the galaxy. There's a foreground star that'll be visible right here. But, so we're at a minute. And, you can start making out something faint right there, which will become apparent soon. So this only goes to 5 minutes. I didn't run it the entire session, but that thing right there, that little star, you can kind of see it's a spiral galaxy or a barred spiral, I forget which, but you can kind of see the shape of it. But that little bit there that's starting to show up, that's the supernova. And I'll let it run till it's almost done here. Almost there. Let me take a drink. So yeah, after about 5 minutes, you can start making out the supernova. Now, I didn't leave it at that. I went ahead and took a much longer photo. I was able to get a 64-minute photo of it. And this was, I think, earlier this week or late last week. It was on the 21st. So, and you can definitely see it right there. That is the supernova. But the other thing that I found really cool about this particular target is we're starting to head into spring and summer, and it's kind of now there'll be more galaxies visible, galaxy season, if you will. There's a lot of galaxies in this image. So here's one, here's one, here's one, here's one. There's on the app itself, there's a button where you can bring up the labels, and each one of these, now some of these, I looked at the photo and I couldn't quite make out that there was something here at the, like these two icy objects, but these definitely you can see. And yeah, I looked those up and they're all, yeah, all galaxies. But then, yeah, and I cropped it in so you can really see. I think I put this on the community board. But then I wasn't satisfied just leaving it at that. So I had, the longest single exposure I had was 64 minutes. And you can kind of make it out, you know, I mean, in this cropped version, you can make it out and you can kind of start seeing these. But this is another example where more data is better. I did a number of 30-minute sessions, and I actually I did it over several nights, and I was able to accumulate a bit over 3 hours worth of data. And so since the Seestar only does a single session at a time, I had to do like I did with that M42, where I loaded it into Siril. I think just about every frame worked. I had a that's another discussion, but I think every frame worked. I didn't use the histogram stretch. I ended up using the GHS stretch to try to manually bring out more detail, but this is what I ended up with. And let me open it up in here. So yeah, I mean, for a little Seestar, I was pretty impressed. So you can really see the supernova there. This is the foreground star. That's the supernova. Like, it's quite obvious in this photo. And this galaxy, NGC 4216, is 100, no, it's like 55 million light years away. But after I processed this will be quick. I ended up kind of going down a rabbit hole because I'm like, okay, that and this is cropped a little bit from the other images. And I had started looking at the labels, but I was finding things that aren't labeled here, or that weren't labeled with the Seestar. And I'm like, what are those things? Oh, oh yeah, I hate it when that happens. Yeah, it's but yeah, look, so I'm like, okay, so here's NGC 4216, and here's some other galaxies, but then that is a galaxy, and that is a galaxy, and that you can tell is a spiral, and yeah, like I started, and then this I think is a galaxy, but then there were um and yeah, that supernova. The reason I looked at it is because it is one of the brighter ones out there now. I think it was just discovered in January by someone in Japan, and it was like 16th magnitude when they discovered it. But now uh, it's like 13th, 12th, 13th magnitude. Um, yeah, and Virgo cluster. I forget. So the problem is here. So I'll get to that in a second. The problem is here. Again, this is where the rabbit hole started. So I mean, again, this is, $500 smart telescope with fairly modest aperture, but functional. And I'm like, and taken in my Bortle 8.9 backyard, and I'm looking at these, trying to figure out what some of them are because they weren't in the app. And this is like 50 million light years away. And I think these two were comparable in distance. But then, so I started looking into, I need to switch back to me for a moment. So I started, God, I only have one screen open, and please bear with me while I switch to this. So I was, okay, oopsie. Okay, so I was, let me switch to the, sorry. Okay. So I started like looking up all these objects. And so, like NGC 4216, because I don't have all these like things memorized. And so, yeah, they're like 70 million, 55 million. So some of those in that frame are at different distances. That's 60 million. And then I started looking at like those IC ones, and this IC one, oh, that's what I was going to bring up. I'll do it some other time. I had actually started bringing up some of these. Actually, I'm going to do this real quick if you'll bear with me. So this one was 123 million light years away. So I'm like, okay, but let me bring up Stellarium real quick. I had it running, but I had to hang on. I had to shut it down. I mean, it got, I hadn't restarted it since I rebooted my computer. Let's see, can I do this? Okay, great. Okay, so because these objects aren't currently visible, I turned off, in Stellarium, I turned off atmosphere and turned off, I'm sure there's a better way of doing it. I turned off ground and atmosphere, so you have the whole 360 degrees of objects visible. So let me go search for NGC. Okay. So we start zooming in. Wait. This always happens. I double click on something and I accidentally, it starts searching for it, but then, okay, there it is. Oops. So you can, there's nothing visible until you turn on or you zoom in far enough where you start seeing the, so this is what we were looking at, or what we were just looking at. So this, this is cool. It's probably taken with like some professional or Hubble. But then if you turn on the DSS, it's a digital Sloan survey, and I start zooming in here, I started seeing, so here's the where the supernova is. The supernova is like right here. And then you see these series of kind of stars right here. And if I go back to this image that I took, you can see kind of this series, and you see this little faint thing, really faint there. I don't know if it'll come through on YouTube, but I can see it. Let me see if I can. You see this thing right here. Okay. So this is where I ended up on the rabbit hole, because I started seeing, okay, that's a real thing. That's not just an artifact, and it's not a star. It's obviously some oblong thing. But even in Stellarium, it doesn't know what the heck this thing is. So I was like, okay, how do I figure out what that is? So it wasn't, I didn't see it anywhere obvious here. So I ended up on this thing called Aladdin, where you can look up things, and it has you can turn on this Simbad catalog, and will it work? Oh, like, I found that sometimes it would flag these objects and sometimes it wouldn't. But let me, long story short, if not, I'll tell you. I'll tell you the punchline. But let's, oops, whoa, wrong way. Make people get dizzy here, zooming through the universe. Nah, it didn't do it. But I'll show you what I did. So I clicked on, when I turned on this Simbad thing, I clicked on, there were rectangles on several of these objects, and so I clicked on that, this particular one. So I clicked on that, and I couldn't find. I don't think I could even find the catalog number. The only thing I could find was, is it even on this one? Yeah, right here, a redshift number. Which, if you haven't, if you didn't, if you never ran across that, redshift can be correlated with distance, especially at longer distances. Anyway, long story short, I ended up plugging that number, the Z number, into this calculator, and it said that this little barely visible speck is 930 million light years away. Yeah, almost a billion light years, which I was like, I'm impressed. I didn't know I could do that, but that's cool. So yeah, I want to. I'm going to take more photos of this area and stack more to try to bring out more detail in this thing. But anyway, I only mention it partly because more data, I was able to get more detail on this photo, but also that led to me wanting to go even deeper because but as far as like what cluster that's part of, I think I forget how far away the Virgo cluster is, but one of the problems, or one of the things I was looking at in this, like there's another cluster in that area that's not Virgo, and some of the galaxies are foreground galaxies. So it might, I don't remember at what, how far away the Virgo cluster is. These galaxies, even if Virgo clusters nearby, might be foreground galaxies. Um, that's the long answer. uh, I'm not sure. uh, but yeah, that was kind of, more data is better, I guess, is the today's takeaway. And more data, even with things that you start looking at one thing, like a supernova in a galaxy, that you start getting data from it within a couple minutes. But it really took, or not a couple minutes, like 5 minutes to get a little faint speck there. But by the time you get to 3 hours, you're to this point where you can really see the supernova, and you're seeing all these other galaxies. And so then that led to a rabbit hole of, what are these galaxies even? I mapped out most of the rest of these. I think the other ones, like not necessarily this one, but they were somewhere all between 50 and 120 million light years away, which isn't close, but it wasn't nearly as far as that little speck that was right there. But it was kind of disconcerting. Not disconcerting. It was pretty cool that like you start seeing these things further and further away, and then you want to like take more exposures to get even further away. But yeah, and I haven't even looked at some of these other things, some of the other things that are kind of more oblong. I think I figured out where this one is, but yeah, there's some things in here that look like stars, like that little speck I saw initially. that led me to realize it wasn't a star. It was a really far galaxy. But there's some neat resources out there, but sometimes it requires a little bit of detective work, because especially when you're starting to get further out like that, um, where the objects are getting a bit fainter, but still 2-inch telescope in a terribly light polluted area. I'd say that was a win. um, yeah, so that's all I have today. Um, oh, I was talking about that supernova without, I think I'd switched off the screen. But yeah, like this is the 3 hour exposure, and then like most of the rest of these things are not as far away. Like, I mean, they're like 100 million light years. Some were slightly under 100 million. Some were slightly over 100 million. This is like 50 million light years away. Although I saw some older stuff that claimed it was 40 million, but the newer stuff was saying 50, so I guess they got better measurements. Um, but then, yeah. So now I want to, and as we get into galaxy season, there's going to be some brighter galaxies that I'm looking forward to looking for with my telescope, or with the telescope, just because they're, they might be like a few 100 million light years away, but they're intrinsically fairly bright, so they should be pretty easy to, or not as hard as that little speck that I found, or that I imaged. I didn't find it. Someone else obviously had found it to get the redshift on it. But anyway, I think that's it. Thanks for tuning in. If yeah, I have a mailing list that I'm going to be sending out information about the eclipse as we're getting closer. So there's a link in the description about that if you want to sign up for that. It'll probably be sporadic, but definitely going up to the eclipse, I plan on sending out some emails on that, just to help uh, help spread more information on it. But that's it. That's all I have for today. Uh, I think this is actually the most people I've had come join on a live stream, so thank you very much. Um, I usually get views after the fact, but I appreciate people showing up live. Um, and I think with that, I'm just waiting to see if there were any comments. But yeah, with that, I think have a good afternoon, rest of your day, and see you in the next one.